Let's move on to FileIO, exception handling, and type hinting. So let's first start with FileIO. Let's first get some input from the user. Let's say my name, input. Let's enter the prompt, which is name. Now, earlier in all the programs, we were taking some input from the users. It was stored in RAM and we were using it in the program. But it can happen that sometimes the input is in a file, or we want to store our inputs which we have entered into a file so that we can use that later on. We don't want to keep inputting like the same inputs again and again and again. And it's a lot of rework, right? Let's say I enter a name and I want to write that into a file, a text file. So how do we do that? We have to first open the file. We have to enter the name of the file. Let's say names.txt. And another thing we have to enter is the mode in which we are opening the file. For example, we want to write to the file, open in write mode. This open function returns something called a file handler. So f is my file handler. Now let's say I wanted to write to the file. I will do f.write. I'll create an f string. Let's say name. Let's write. So let's run it first. Let's pass one name. I entered my name. So now you can see that there's a names.txt created. So it's working, but a standard practice is that when we write to a file or do whatever we want with the file, at the end of everything, we have to close the file. Sometimes the output can be corrupted because of this. Let's run it again. So earlier my file was there. Let's enter again. Let's say now my name is Ravi, and let's look at the output. Let's enter the new name, Rani. See, the problem here is that this mode W is overriding the file again and again. We don't want that in this example at least. So there's another mode called append mode. So it will append at the end of the file. Let's run it again. Let's say Devendra. Let's see the file again. Now another problem is that there's no separation between the two names. We'll add that. If we add a backslash n, every time I run it, it will be in a new line. Let's remove names.txt, clear the screen, run it. There is my first name. We have it here. Let's run it again. Let's say Rani. So it's working as expected. Now it is appending at the end of the file whenever we run it again. Let's add something more, Roshan. So it's working as expected. This is fine. Now what happens is a lot of times we forget to close the file. And if you don't want to do that, there's another way to write it where it will automatically close the file outside its scope. So what you have to do is slightly modify it. We use with keyword as f, and we can remove this. So this new code does exactly the same thing which the previous code was doing. Let's run it again and add one more name to it. Let's add Harry, and we can see the new name. So this is how we write to a file. Now let's modify this and see how we can read from a file. So there's another mode called read mode. If you want to read from the file, and there's one function called read lines which reads everything. Let's print it first. Print lines and see what it gives. So for at least for this one, we don't need this input because we are reading. See, so f.read lines reads the whole file and returns it as a list of items or a list of strings in this case. So what we can do is we can operate on it, right? Let's say now what I want to do is we have read it, the file, the handler is closed. Now we can do for line in lines print f string hello and then the name of the person. Let's run it. So what we can see here is that there's an extra space every time we see, so we can use an extra argument which is provided in print function, where we say that the end of each line we don't use any character. Earlier the default value was \n. Let's run it again. See, it works. Let's see our test code, names.txt. So we have these four names and we are able to print those four names in the same order. What else can we do? Another option is that instead of this, we could directly modify the string and say we want to strip. Let's see, it should give me the same results. It works. So this all is good. So there's one more way to write all this, a much shorter way. What we can do is directly use the handler, and this will also give me the same results. See, so this is another way to read the file. Now, now let's say I wanted to print, but in sorted order. So I wanted to print hello and names of all these, but I want the names to be in sorted order. Only the names, not the sentences. So one way to do it is we can create a list and again use the read lines function. There's another way to do it is we could directly use name to append. Let's print. See, so we have names list which has all the names in it. Now let's say I wanted to print the sentences. Let's do it first for name in names print hello name. See, but what we want to do now is print in sorted order and sorted by names. So we will use the function sorted names. Now you can see that the names are sorted alphabetically. We could also reverse the sorting order. There's another argument called reverse, which is by default false. If you say reverse equals to true, now the order will be reversed. See, reversed. So now let's say I wanted to read from a file, but let's say now each line has multiple values separated by comma. Let's say my address is Bangalore Jam Pot Jam Pot. So now what we can do, right? Maybe use a different name because now it's not just name. Let's call it data. Now what we can do is we can say name comma home is equals to row dot split on comma and we can write name from home and it works, right? Now let's say that someone writes gives an input like Bangalore, comma India, and it's also a separator. Now this could be a problem. Let's run and see what happens. See. Now the problem is that when we split, we have three items. We split by comma, but we are accepting only two. And you can imagine that data can have separator. So either there's many ways to do it, but the thing about libraries in Python or any language is that we can reuse all the work of someone else and make our lives easier. And if you are aware of CSV, if you have this in inverted commas, it kind of works. So there is a Python module called CSV, and now we can see how we can solve this problem. Because earlier it was very complicated. So again, we use the same thing. We open the file in read mode. We have a handler F. The new thing here is that we create a CSV handler, CSV dot reader, Now it's just the same. Instead of F, we use reader. Now CSV returns. Let's first print what data we are getting. See, CSV reader is able to read correctly. We have two items. The second item is Bangalore, India, and it has a comma in it. So at least the reading part is working as expected. And we can also see that every line in the file has been converted to a list. So again, we can do the same thing. But now because it's already a list, we just need this. Let's try it and run it. It works. And it works. Right? But now the problem is that we need to know, right, that the first item is name, second item is home. And this is a standard CSV format. That first row tells you the column names. Name, comma, home. Now you have that. This is another functionality in CSV which kind of reads the data in dictionary format. It's called dict reader, dictionary reader, and nothing changes. The change obviously will be that this is now a dictionary. Go home. Let's run and see. It should not change. But when you look at the input, see we have a list of dictionary, and it's more friendlier than before because earlier it was kind of like a list. Now let's say we don't need this. It works. So now let's say I wanted to print again in sorted order of name. So we can again use sorted data, but now we have a dictionary and it won't work. So we need to give it a key. One way to provide the key can be through a function, but we'll use lambda function. Lambda function, and we say that we will take the name key, and now it will be sorted by name. See, now it is sorted by name. Similarly, if we wanted to write to the file, what we can do is get input from the user. Let's say home is equals to input home, name is equals to input name, and we have to use append mode because we don't want to overwrite all the data. We want to use writer because we have just one input. We will write it. So we will say writer dot write row, and it takes a tuple name and home. Don't need all of this. We are writing to the file. Let's run it. Let's add a new name. Let's say homie is the name. Location is IISC Bangalore. So we have actually added this to our names.txt, and see how the library has directly understood that the input has a separator inside it. So I will keep it in quotes. So while reading and writing, it will take care of it. There's one more way to write to the file using CSV module. Similar to reading, like dict reader, we also have dict writer. So it takes the handler and it also takes field names. So let's add field names, name, home. We have a writer here now. Now we have to just create a dictionary we want to write. So we are doing the same thing, but with a different syntax where we are passing on a dictionary. Here, let's look at the current state of file. Now we have to think of a new name. Let's say I call the new person Sam. He lives in Bangalore and it works. So this is how we can handle FileIO in native Python. Let's now move to exception handling. So let's clear all this up. So let's start with a very simple function, hello world. But let's say deliberately I remove the double quotes. And of course, there's an error here. It shows string literal is unterminated, but let's run it. See, we get a syntax error, unterminated string literal. So we have started the string literal with the double quotes, when we have to end it with the double quotes. And now the error is gone. Now it's a terminated string literal. And now it will work. So this type of error is called syntax error, and we have to always handle all the syntax error before we can even run it. But there are other kinds of errors which happen during runtime, and we should be able to handle it. Let's take another example. Let's say x is equals to int of input enter x, and then we print a string x is x. Let's run it. So let's say x is 10 and it prints x is 10, maybe 0, x is 0. Run it again. Let's say x is 20. It works. So you type positive number 0. Let's try negative number. Let's say minus 10. Still works. So it feels like the program works, right? But we have no control over what the user does. So let's try another input. Let's say the user enters like ABC, which is like a string, and now we get a value error because string ABC cannot be converted to an int. And this is an example of runtime error. Like on some kinds of input, it works. On some kinds of input, it throws an error, value error in this case. So how do we handle it, right? Because these are, you cannot always control what the user can enter. So one way to do it is via try except block. Let's see it in action. So what happens is we will add inside the try block where we think a specific kind of error can occur. So it will try to get an input, convert it to int, assign it to x, and then print our result, which is x is, and then whatever the user entered. This it will try. Let's say if for some reason there's an exception. So we have an except block for that. So let's say I handle the exception so that if there's a value error, I can print x is not a valid value, or more specifically, x is not an integer. Now let's see what we get. We enter a positive number, we enter a negative number, we enter another positive number, 0, kind of works. Let's go with ABC again, and it didn't give an exception. It was handled, and it prints x is not an integer. So this is how, by using try except block, we can handle runtime errors. And of course, I mean, one more thing is like we want to keep minimal amount of code in the try block. So sometimes we can actually bring it outside, and that's fine. So of course, this has some runtime error, but let's discover it. Let's say enter 10, it works. The negative number, it works. 0, it works. Okay. 0, it works. Now again, I enter my string and it fails. Why? Because the failure happened here and it was not able to assign it to x. So there's no x right now. So there's another part of this try except block called else. So it's more like if exception didn't happen, it will do the else part. Let's enter our use case ABC and it says x is not an integer. It skips this. Let's say I give a valid value 10 and it works this time. So this is kind of try except block. There's another thing we could do is like we can keep this in a loop and we keep trying again and again till we are not getting a valid value. And once we get a valid value, we return the valid value and use that value and print our output. That is obviously a possibility. And this was about handling exception. Now, another thing I just wanted to touch upon is testing or writing tests. So let's say I have a very simple program, let's say called cube of x returns x cube, and if you print cube of 2, it should give 8. It gives me 8. Now, how testing kind of works in programming world is we create a new file. Let's call it test underscore program.py. Now what we can do is we can import our function we want to test from program import cube. Now let's say I wanted to test cube. So in testing, there's an assert keyword which is commonly used. Let's use that. Let's say assert cube of 2 is equal to 8. Right? We can have another thing. Assert cube of 1 is 1. Cube of -2 is -8. Let's say these are the ones. Now, there is a library in Python for testing called PyTest. And how you can install it, I'll show you. Python -m pip install PyTest. It's already installed for me, but this is how you install. I can show it again. Python -m pip install PyTest. So once you have done that, you could use PyTest test underscore program.py and it will run it for you. See? So there was one test, which is one function, and it passed. Let's say I make some error in the program. I say, let's say x is equal to x plus 3. Now I run it again. Oh, there's an error, right? See, it failed at assert 5 equals 8. That's one thing. Another thing is that we might want to cover various situations. Let's say I have a function for covering positive inputs, negative inputs, 0 inputs. So now what we have done is we have created 3 tests and each test is run independently, and if there's no exception in each of these test cases, each test case will be passed. Let's go back to this. This is also correct now. This looks okay. Let's run it and see. It says that 3 tests have passed, which means all 3 have passed. And if something is not working, let's say if I say x plus x, now it is not correct, but some test will pass. See, 2 tests have failed, 1 have passed, and it shows the failed test. Positive and negative cube tests have failed. It tells the first assert where it failed, and it ran in this many seconds. So this is how you can write tests. Of course, it's a lot of work, but this helps us to write automated tests in a sense that once you do it, that part is covered, and whenever you write the new code, you write new tests for that. One more thing is you could have like a folder for tests, and let's say my test program is in this folder. So one more thing you can do is like there could be many files, many test files. So we keep all those test files in the folder test. And if I just write PyTest test, it will run everything in the test folder. Okay. So what is happening is basically it is not able to find program. So because test underscore program is now part of this test folder, it is not able to find this program. So one way to do it is like relative to this program, we could have added the path above it. So it's more like we have just added path where this program is. Let's run it. See, it works. Let's fix it. It was cube, so we can do cube Okay, it passed. So we can see three tests and it passed all three tests, it can see. And this three dots is also a way to tell you that all three test cases passed. Let's make an error again and see. So one thing is three tests failed, and you can see here the state of all the tests. F means all the tests failed. So let's make it x plus x so that one test will pass. Yeah. So you can see that the first two tests failed and the last one passed because 0 plus 0 is 0 and 0 cube is also 0. Let's fix it again. So this is all about PyTest. Of course, it provides like a lot more functionalities. You can look at the documentation, but this is pretty easy to use and set up. Let's clean this up and let's look at type hinting. So let's look at it first, then we'll talk more about it. Let's say we have function greeting, which is accepting a name and number of times we want to print the greeting. Then we can return an f string which says hello name into n. Now let's say I want to print greeting two arguments. This works. Now the thing is, let's say if user was entering it, right? Name, input, enter name, n is equal to input, enter n, and you can use name and n. Now obviously this will not work, but let's run it. Name is Dev, n is 1, and see, because this is expected to be an integer, but it's not, it's a string. So we'll convert it to integer and now it should work. See, let's run it for some other number, let's say 3. So now what we can see is that we don't have any new line. So we can add that. Let's run it again. Got it. Anyways, we can always use and equals this because we have everything in the string we need 3 and it works, right? So the thing is that still this code has an issue. Let's look at it. So let's say I enter my name, but no one is stopping me to enter some string here, and it kind of gives me a value and all those things. Let's look at it. So let's say I enter my name, but no one is stopping me to enter some string here, and it kind of gives me a value and all those things. So what is type hinting? First thing is type hinting is only for documentational purposes so that when someone looks at your program, they know what type to expect. So let's just look at it, all of them, right? First thing is here, this name. How can I give a type hint here? Like this colon star, colon int. Here also you can add the same thing, colon int, colon star. And we can also provide hint for return type. How we do that is like this hyphen and this greater than sign and then star because we are returning a string. So this is all type hinting. So nothing will change in terms of how the program runs. It works as expected. But one more thing is like here we have everything. But let's say how does a programmer understand that his code is actually following the type expectations? Let's say I remove this int here. Let's say I also have a default value for n, which is equals to 1. Let's run it. This will of course show an error, but we could have also used a casting here and it would have worked. But the problem here is that in line number 6, n should be int, but what input gives you is a string. So these inputs ran successfully, right? But actually it's an issue. So how we discover it? So there's a module called mypy. How do we install it? Python -m pip install mypy, and it's installed. This is the command Python -m pip install mypy. Everything is fine. Yeah, clear the screen. Let's run it again. See, so what MyPy is done is it looks at the program, it looks at the types returned, what is the type expected, and so on. It tells me that it has found one error in one file and it's checked in one source file. And what is the error? Incompatible type in assignment. Expression has type str, variable has type int. Line number 6. It says program.py line number 6. Now, if I add int here, now the type is matching. And now if I run mypy on this program, it says success, no issues found in one source file. So of course, Python doesn't enforce matching the types when we write the program, but there are additional libraries which will help you do that. So this is one example of type hinting. Let's just remove it because it will never happen. It will throw an error before it happens. Right. This is fine. Let's just run it. Let's print it 5 times and we get it 5 times. Now there are more advanced typing. So we will use a module called typing. So from typing, import, we will import types like dictionary, list, set, people. Let's clean this up. So earlier my list was, let's say this, 1, 2, 3, 4, 5. If I wanted to give a type hint, what would it be? It would be list, square brackets, int. This just means it's a list of integers. T is equals to, let's say it's a tuple, and let's say it's like 1, hello, 3.14. So if you're very specific, then maybe you can add a type tuple and you can hint for each location int, stir, float. Similarly for a set, right? Let's directly write it. We will hint it's a set of ints equals 1, 2, 3, 4, 5. Similarly, if it's a dictionary, we will hint dictionary. Let's say key is a string, value is int. Then the dictionary could be something like A:1, B:2, C:5. So we have type hinted here, right? Let's say I run mypy on this program.py. No issues. Let's say I add one star at the end. Let's run it again. See, it finds an error here because the type is not matching. Of course, it will only check what is possible. So there's another, if you go to union, let's see that union in action. Let's say I have a list which is of mixed type, like 1, 2.5, 3.14, 5. This is decimal. So what can you see? It's neither int nor float. So when we hint a type here, what we can say is it's a list and the type would be union of int and float. So it could be only int or float. So let's run mypy. Okay, we have to write a new L2, let's say. No issues. So there's one more thing you can do. So what happens is sometimes let's do that first. Let's write our previous function greetings. Greeting name. Name could be a union of string and none, and default value could be none, and return type could be a string. Now we can return an f string hello name. If name, else we can return anonymous. Let's use single quotes because outside we have double quotes. Now let's print greeting. Let's run it. See, hello anonymous. So what we have done is basically the type of name. So none is its own type, and name could be a string. And if the user doesn't provide anything, it will be none. So the type here is basically either name could be stir or name could be none, any of these types, and the default value is none. Now there is one more type called optional. So instead of writing this long thing, we could have just used optional stir, and this is effectively the same thing. Instead of using union stir and none, you could use optional stir. Let's run it again, and it works. Sometimes we have complicated types. For example, previously we were seeing this tuple, right? The first one could be an integer, the second one could be a string, the third one could be a float, right? And what was my previous type? It was tuple, then int, stir, float. This was it, right? So what we can do is basically we'll take this type and we can give it a name. Let's say we name it int stir float tuple. Int stir float tuple. And we can use this type here. Right? Let's run my query program. Success, no issues. So there could also be custom types. For example, we learned that creating a class is like a custom data type. So let's have a like super simple class called post. We define a constructor where self dot title is equals to title self comma title int star. And let's say I have another function star return self dot title. So let's say this is my class. So let's say I have something like post equals to post title will be post a, right? So let's say I create two objects and put it in a list. What is the type of it? The type will be list of post. Let's check it on with MyPy and no issues, right? So this is how we can also, while type hinting, we can use user-defined type as well. So there's another one called any. Let's use it. First import it any. So we define f x of type any, and return type could also be any, and we just return x. Now let's try it with different data types. So let's run it. Python program.py, it works. MyPy program.py and success. So this is any type, right? Which could take on any data type. Now let's look at a very complicated example, callable. Let's clean this up. So let's say I have is the even function which takes an input, type is int, it returns a boolean, it returns I mod 2 equals 0. This is even function, it returns a true if it is even number, false if it is not. Now let's define a function filter list, and it takes a list L, and it takes a condition and return I for I in L if condition I. And let's say I have a list L which is 1, 2, 3, 4, 5, 6, and we use this function filter list L comma is even, and it should work. First run it, then we'll add types. See, so from the list L, the even numbers are 2, 4, and 6. Now let's think about it. What is the type of L? If is even takes input int, what is the type of L? First thing is it should be a list. That's fine. And the list is of type int because is even works on int. That's one thing. Another thing is what is this condition? Basically, it takes function name as an input. It's function. So we can write, let's say, condition function. Let's say that's a type we will define very soon. Let's define it. So condition function equals, first thing is what is that function, right? So function type is basically a callable, and the input is like list of int and output is boolean. See, this is how we can hint when we have an input as function name. Let's run it. The result should be the same. We run with mypy and it's success. So everything works, everything is fine. What else? So filter list, this part is done, and it will return. And the return type is list int. Again, I run mypy, no issues. I run the program, no issues. Everything is working. So this is all about type hinting.